So I'm going to be talking about testing your RxJS code. I'm Jay Phelps. If you want to reach out to me on Twitter, you can at _ Phelps, JayPhelps. I'm the co-founder of a company called Outsmartly, and we deal with, we're coming out of stealth mode, and we deal with performance. So I'm just going to jump right in for time's sake. So there are numerous ways to test RxJS code, and I'm not going to cover all of them, but I want to start by saying that testing async code is really, really hard. Even with the things I'm going to teach you today, it's still really hard. And there's a lot of caveats depending on what environment you're testing it in, like whether you're in Node, you're in browser, you're trying to test it in some weird JavaScript environment. There's a lot of caveats. So unfortunately, I can't cover everything. But let's start simple. So let's take some very simple JavaScript. I'm going to assume that you know how RxJS works and all that stuff. So if you have trouble with some of this, you might have to come back. But here's some very simple JavaScript or RxJS where we've got an observable of 0 and then 1. So it'll emit 0 and then synchronously emit 1 as well. So you can see that it console logs 0 and 1. Now, if we were trying to test this, like we wanted to make an assertion for the value, the callback gets invoked for each individual next value. So we need some way of accumulating all of those values. So one thing you might decide to do is you might reach for the toArray operator, which will basically accumulate all the values, and then once the observable completes, we'll emit them as a single array. So you can see there that it waited to the completion and then emitted 0, 1 as an array. Now you might do something like this. So if you were using Jest or something, you might call expect value to equal 0, 1, right? And this works. This absolutely is a legitimate way of testing RxJS code today. However, there's lots of footguns with this. So what happens if I swap out that input with an observable of interval? And so every 1 millisecond, it's going to emit something, and then we're going to accumulate it to an array. Now, remember how I said that toArray waits for it to complete? Well, it never completes. So it's never going to be called. So your test will just lock up, right? So you could do something like this. You could say take 2, like I'm just going to test 2 of them. And that works. That is legitimate, but there are caveats again with that. Your test is no longer actually testing that the code never completes, is one of the problems. And the other problem is that what if we don't actually test that, like the concept of time in this test. You know what I'm saying? Like the fact that it's 1 millisecond between each value, we are not representing that inside the subscribe and the expectation, right? So it does not actually represent that each value is emitted after 1 second. And let's see. So, and the second problem is that if you are using a test runner, you have to somehow signal to the test runner that you're done, because this is asynchronous, right? So I'm not going to go into it deep because it depends on the framework, but generally speaking, there's some sort of callback, see how we said done there. But the problem with actually using real timers, there's several of them, but the first big problem is what happens if your timer is something like 10 seconds. And by the way, just a little side note, if you're using modern JavaScript, you can now use the _ delimiter just to make the numbers prettier. So you can see that it is actually 10,000 milliseconds or 10 seconds. So if you were to run this, you would actually have to take 10 seconds for each individual one to emit. And let's say you got tons of tests that are running this over and over and over. This can make your tests run for minutes or even hours, depending on how many tests you have. So it requires real amount of time to actually pass, which is troublesome. The other problem is if you make anything non-trivial, like this was a very trivial example, but if you make anything non-trivial with real timers and you've got a bunch of them running and stuff like that, you create a lot of non-determinism, which that effectively means flaky tests, that things can go in different timings, different orders. There's just all sorts of weird things happening, and that's never a good thing, right? So you want your tests to always either pass or fail, not sometimes pass, sometimes fail, right? So what are our options? Well, what we really want to do is we want to test our asynchronous code synchronously and deterministically. So right now it's asynchronous, but we want to actually test it synchronously, even though it is async, and we want it to be deterministic. Every single time is the same thing. And the only real way to do this is to virtualize time, to you take the concept of time and you create a fake clock essentially, and you're able to control time. You could go forward, backward, etc. So one of the almost obvious ways is to fake out timers, right? You override set timeout or in set interval and all of those sorts of things. And then you can advance time, trigger it as you please. Lots of frameworks can do this for you automatically. There's NPM libraries. That's a whole talk on its own. There's no point in getting into that. But here's just a general example. You could say just use fake timers if you're using that, right? And then I could advance time by 1 millisecond and then advance time by another millisecond, and then you get the two values. But we're still, if you're a clever cookie, you might notice we're still not actually asserting that time has progressed, right? We're advancing time, but we're not actually saying that that was the real reason why we got 0 and then 1. We're not actually asserting that sequence is the timing sequence. So you could change this code and you could write it into a buffer, right? You could push each value and then you assert it on each step that this is the one that came here, and then now this is the one that came here, and that works. But this is imperative, which isn't the end of the world. Sometimes imperative is fine, and sometimes that's what you should do. Just makes things simpler. But complex sequences can be very difficult to coordinate and reason if you're using this technique. So is there another way? And just to be clear, you sometimes will want to use that just because there's sometimes that it's just like, that is the easier solution. There's no one size fits all. But can we declaratively represent values over time? And the Rx community, not just the RxJS community, but the Rx community at large has kind of popularized this concept of marble diagrams. And if you hadn't ever heard of them, I'm going to kind of give you a quick primer to it. So here's some very basic JavaScript. For every time I click a button, we are going to debounce it for 500 milliseconds, right? So if we were to break this down, we would create marble diagrams like this. We'd say, here's an example of an input. So the top is showing us the input from the clicks. So let's say, you have the green click and then the yellow and then the blue, et cetera, et cetera, et cetera. And then the bottom marble diagram is showing the output of the debounce time operator, right? It debounces it every 500 milliseconds. So let's actually run through that. Let's throw all that away, get rid of that, and then actually run. So we're going to start at the left. Time starts at the left. And then we start clicking. So I'll click once, right? Then we wait 500 milliseconds. And that marble is going to get emitted by debounce time because I waited enough time for it to emit it. Now let's say that I go and I click again, and I click again, and I'm just like rapidly clicking, keep going. Now 500 milliseconds have actually passed. It's going to emit that last one because that's how debounce time actually works. Then again, we keep going. I do another click, 500 milliseconds passes, and then it emits again. And so this is a marble diagram to demonstrate, once you learn how these marble diagrams work, and some of them are much more complicated than this, but once you learn these, it's very simple to look at these operators and see, oh, okay, so that's what it does, right? So marble diagrams are great, but how do we represent marble diagrams in our code, right? We can't put graphics in our code, can we? Well, we kind of can. ASCII art. So to the rescue. So we need some way to represent the marbles in ASCII. So here's an example marble, right? Green. Well, we could represent it instead of with colors. We could represent it with letters, single characters. So a green marble might be A, right? So, and then you could say that A by itself means that A emits synchronously at 0 milliseconds. It's the very start of the stream. It just synchronously emits A, whatever A is. Now, what if we wanted to emit A and then 1 millisecond later emit B? So asynchronous. So you emit A synchronous, then asynchronously emit B, right? One after the other. So you could put them right next to each other. And that could mean that this one emits at 0 milliseconds, this one emits 1 millisecond later, right? So that's pretty straightforward. A emits, then B emits synchronously after 1 millisecond of virtual time, okay? Now, so that's 1 millisecond later. What if I wanted A and B to both emit at the same time on the same frame? So at 0 milliseconds, at the very beginning, it synchronously emits A, then synchronously emits B. Well, we could come up with some syntax for that. We could put them in parentheses. And that now means that they both emit at the exact same frame. So they say A emits, then B emits, both synchronously, right? A emits, then B emits. Now, let's see. So what if we wanted to say, so this was 0 milliseconds and then 1 milliseconds, right? What if we wanted B to come at 2 milliseconds, not 1 millisecond? Well, we want to put something in between here to signal that a millisecond has passed, an additional millisecond. And because of a marble diagram has this lines through it, we could just use a hyphen, right? Just hyphen that through, and then that now represents this is 0 milliseconds, this is 1 millisecond, this is 2 milliseconds of time, right? So A, 1 millisecond passes, then another millisecond passes, and then B. And we could do, that way we could do 3. So we could say 1, we could say 2, and then 3, and we could just keep adding on more and more and more, right? But what happens if we want to represent, say, 10 milliseconds? It would look something like this, which isn't that bad, right? So you got 10 milliseconds is all the way to there. But things get really hairy because very often in real life, you very rarely have very short timers. They're usually like 100 milliseconds or 1,000 milliseconds or 10,000 milliseconds. So you get things like this. And this was a problem with the older versions of RxJS, like version 5 and stuff. But we came up with I forgot to mention, I used to be on the core team. I'm not anymore. But we came up with a different way of handling this. So this would be 100 milliseconds, but this is just not untenable. So we need to come up with some way of representing a specific amount of time has passed in a very terse way. And the most obvious way is taking inspiration from CSS, right? So we could just say time has passed. So in this case, we're saying 99 milliseconds has passed in between there. So this actually emits at 100 milliseconds now. And that's a very terse way of saying that. Now you might be looking at that and going, why is it 99 milliseconds? Why isn't it 100 milliseconds? And this trips people up. It trips me up too, I forget. But it's kind of a quirk, yet a feature. It really depends on your perspective and preferences. We debated this a lot. But if I were to use 100 milliseconds, this would actually end up being 101 milliseconds, which is not what we want. And the reason why is because A starts at 0, but every single letter, every marble you have, when it's standalone like that, it represents a frame, 1 millisecond. So even though the A gets emitted at 0, time then passes 1 millisecond no matter what after A, unless you group it together with the parentheses. So A emits at 0, but then advances the actual timer by 1 millisecond. And that really kind of trips people up that that each marble takes up a frame itself intrinsically. And that's, you just got to kind of get used to it, and then it kind of becomes a little bit more intuitive. So 99 milliseconds is what you actually want to get 100. Next up, what about, so that went on for 10 milliseconds, but we didn't say anything about the marbles actually completing. What if this stream actually completes and doesn't go on forever? What about complete? So we need a symbol for that. We need some way of representing the end of it. And when we had the graphical the graphical marble diagrams, we had a line at the end that represented the end of a stream. And so why don't we just use that? We can just use the pipe letter, and that can now represent that the observable has completed. So we're saying that A will emit, and then 100 milliseconds later, B will emit, and then at 101 milliseconds, you'll actually complete. Because remember, each marble takes up 1 millisecond frame. So B actually does take up a frame, right? So, but let's say that you want to emit B. That actually doesn't happen very often, where something emits a value, waits a whole millisecond, and then completes. That's pretty abnormal, actually. So more common is you want to say emit a value and then complete synchronously. And to do that, remember how we do synchronous. Remember how we do multiple things synchronous. We use the parentheses. So we wrap those in parentheses, and now you're saying that B is going to emit, and then we're going to complete synchronously on the same timeline, right? So that's the very basics of marble diagrams. We'll touch on a couple more, but all we have to do now is put this in a JavaScript string. And now you have just learned the basics of ASCII marble diagrams for RxJS testing. So let's actually write some code. So we go back to that using fake timers just example. We break that back down to its basic parts. How would you represent this stream as a marble diagram? Well, it looks something like this. So here we say 0. So we're skipping a frame. So we wait 1 millisecond because that's how interval works. It doesn't emit synchronously immediately. It waits the time, then emits the first value. So it waits it's right now we're going to wait 1 millisecond, then it will emit A. Then it'll wait another millisecond and emit B, and then synchronously complete. Now, synchronously complete, like we only added the take 2 to get around the fact that we couldn't represent time going on forever or whatever. Like we added that operator for that purpose. So do we really actually need that? And the answer is yes and no. You kind of like, so what we really want to do is get rid of that that take value. This is how we want to represent this as truthful, because that is exactly what this interval is doing. 0 milliseconds, 1 millisecond, then 2 milliseconds. Input never ends by design because that's just what interval does. So you could add like another C or another marble or a ton of marbles because it just goes on forever because there is no take. And that was how we wanted to use the code. But that is problematic because even though we're virtualizing time, we can't advance time to infinity, right? You know, like we can't actually get an infinite number of values. So we have to stop it at some point. Like even though we want to represent this as saying it's infinite, we don't want to actually be infinite because if we tested it infinitely, it would just never end. So we need to write a diagram to represent the subscription that we're going to use for testing purposes. So here's a diagram for subscription. We're saying that 3 frames will pass, so 3 milliseconds, and then infinity, right? But we actually do want it to unsubscribe, so we can put the exclamation point. And if all this syntax is kind of confusing, don't worry about it. You can go to the documentation and use this as a reference until you learn it all. So another kind of cool thing about the newer versions of RxJS with the ASCII diagrams is that one thing that's really helpful about them is that you can add arbitrary white space and it means nothing now. So that means I could actually do this so that now the ASCII diagrams I can have, like I could have a bunch of ASCII diagrams and they'll all line up aesthetically so that you can visually see like, oh, okay, that's when this happens, that's when that happens. And it becomes nice and easy and intuitive to reason about it. So that's marble diagrams. How do I actually use this? Because JavaScript has no idea what this is, right? You need to use something called a TestScheduler, and that's provided by RxJS. It provides that first-class time virtualization. So you can import that at rxjs/testing. You need to instantiate it and provide a callback. The callback is going to accept 2 arguments, the actual value and the expected value. And then you need to integrate this with your testing library of choice. Like here's an example using Chai, but you could just as easily use Jest or some custom thing, but you're saying you're expecting the actual to equal the expected. And so under the hood, it will call this for you when you do your test assertions. Now you need to keep a reference to that test scheduler, and there's this run method. And inside the callback that you provide, time is automatically virtualized. So you don't need to, if you used marbles in the past, with the new run method, you no longer have to pass in your own test scheduler to all your different operators or thread that through. It just automatically threads that through for you and automatically virtualizes time. If you have no idea what I'm talking about, just ignore that statement. But the gist is that it just magically works. You don't have to do anything special inside that callback. It also gets an argument called helpers. And it has a bunch of things on it. Let's first start with expect-observable, which is a helper to be able to do assertions on your streams. We'll add that code we were working on earlier back in here. And then we can just write a little code to make that assertion, to actually use that marble diagram. We're saying expect the output of this observable to be this expectation marble diagram, right? Pretty straightforward. Now, one thing we haven't touched on is that we were using A and B and C as marble placeholders, but our real code is not going to emit A, B, C, D, E, F, G, right? So we need some way of still using the letters to tersely represent the marbles, but we want to actually have real values for them. And to do that, you can pass a second argument to the toBe function that you're chaining on expected observable, and you just provide an object as a dictionary to look up the different marble terms. So you have a value for A and a value for B, et cetera, et cetera. Pretty straightforward. If you were, I would say, so like back in this example, we have our input code hard-coded in our test, which makes no sense. No one ever is going to do that, right? You have an application, your application code is going to be where it is, then your tests are going to be somewhere else. So it might look something like this. This is a trivial example, but still, you have some example code, and then you're going to somehow, import it and use it later. So let's say that we imported it. I'm not going to show all of the code, but let's just say that we imported it into our test. We could write a marble diagram for that. And then we want to write our subscription logic so that we make sure to unsubscribe, because it will go on forever because it's an interval. So 5 milliseconds, then A, then 99 milliseconds, then B, and then we unsubscribe because it's doing throttling. So if we throw that in an actual test, let's say using the it helper in Mocha or Jest or what have you, so it does cool stuff. We call test runner, our test scheduler run. We provide our boilerplate that we had there. We assert that the observable is our marble diagram. We expect it to be there. And then we provide those two values for that we would get back. Now notice that it's 0 and then 20. And that's because of throttle, right? Instead of 0 and then 2 or 0 and then 1, we were throttling for a bunch of time, and 99 milliseconds passed, and then we actually emitted B. And so that's exactly why. And if that's confusing, just kind of play around. The best thing you can do is just kind of play, see what happens, and you'll go, oh, okay, that makes sense. So the other thing that I want to tell you about is the cold helpers. There's cold and hot. It's been cold. What does cold mean? What does hot mean? Has been touched on a little bit before. I'm not going to go too deeply in it because it is a talk on its own. As mentioned before, Ben Lesh has a wonderful Medium article on this. Just search hot versus cold observable Ben Lesh and you will find it. It's wonderful and explains it. But the gist is that there's a little helper for you to create your own custom observables very, very trivially. So you could say cold 5 milliseconds emit A, 99 milliseconds emit B, right? Pass in some custom values to it. And now the test will run just as it was. Now there's also a hot version. So if you swapped out cold with hot, you'd have to change the expectations, because basically if you decide to subscribe, that's what the bottom sub thing is. And I'm not going to get too deep into this, but there's this little, the caret. That's basically saying that's the point I want to actually subscribe. So the hot observable is pumping out values even before we subscribe to it because it's hot. And once we've subscribed, we've missed a bunch of values, right? So we need to update also our actual asserted value. So we missed 0, we missed all the other stuff because it got throttled. Then we only picked up on 20. And that's the gist of hot versus cold. There's also assertions. Or assertions for errors, I mean. So like, let's say we do A, then the 99, and then B, but instead of doing B, actually what happens is it's coming back from the server or something, and there's at 100 milliseconds, there's actually an error. And so we can replace that marble with this hash symbol, right? And the hash means error. It's the equivalent of observer.error. So when you provide a subscribe, when you subscribe to observable, remember how there's 3 callbacks. There's next, error, and complete. This is saying that the error channel is going to get hit because there was an exception. There was an error in this stream. So if we go back to some basic code, we could create a cold observable saying that after 1 minute, we just error out. And that will be our very simple expectation. We say after 1 minute, we receive an error. And that's exactly what happens. Now, if we wanted to provide a value for that error, we can't use the second argument because that's a dictionary for the A, B, C, Ds, right? For the marbles. And this is not a marble, this is an error. And there can only be one error because once a stream errors, it doesn't happen again. So it's the third argument. So that one, and the third argument, you can pass that error value if you want. Otherwise, if you don't have an error value, you don't need that assertion. So in this case, we're throwing bad stuff, and then we want to make sure that, in fact, we really are throwing bad stuff. So if that all was confusing, or maybe even if it wasn't confusing, you might want to learn more about this. There's a couple things that I kind of skipped over, variations to this, and also some more examples as well that you can find at rxjs.dev, and then guide testing, marble testing. The other thing you can do is you can just search RxJS marble testing, and it's one of the first. It might not be the first, but it's one of the first results. One thing to keep in mind when you're trying to learn more about this is that marble testing has gone through a couple iterations. And so there are outdated documentation, like third-party documentation, third-party videos and stuff like that that people have mentioned. So the thing to quickly notice the difference is that the old version, spaces were, like if you added white space, that meant something. And in the old version, one frame was 10 milliseconds, which is weird, but that's how we did it. And then the other thing is that the test scheduler didn't automatically get injected. So in the old version, you had to actually pass the scheduler to all your time-based operators, which is a pain in the butt. So if you start looking at documentation like that, you know you're looking at something outdated, because the new version, you don't need any of those things. So if you have any questions, I'm happy to answer them. Or if you just want to chat RxJS or other cool things, you're welcome to reach out to me at Twitter at _JPhelps. Remember the underscore. And thank you all very much.